We know with some assuredness that the access for maxillary single-rooted premolar is wider buccolingually than mesiodistally, reflecting the typical coronal anatomy of the pulp. That is what you are seeing here in the initial access we are gaining to the pulp chamber. Note how my initial access is not wide enough in the buccolingual dimension to engage the full width of the pulp chamber in this plane. By extending the access buccally and lingually, I remove undercuts, providing for straight line access for the safe-siders that will soon be introduced into the canals. Following irrigation, I introduced the .10 safe-sider into the canal and noted it was so loose in gaining access to the apex that I immediately jumped to a 20 safe-sider. At first, I negotiated the 20 safe-sider to the apex manually, noting its correct length. I then attached the 20 safe-sider to the 30-degree oscillating handpiece at 3,000 to 4,000 cycles per minute and worked the walls vigorously, something I can routinely do without concern for instrument separation. In large canals such as this, I often place a 30-degree bend in the last couple of millimeters to better remove any pulp debris that may be present along the length of the canal. After irrigating the debris from the canal, you can see the advantages of placing a small bend at the tip. The canal is practically free of debris, having instrumented no further than a 20 up until this point. The canal was now prepared adequately for me to jump to a size 30 safe-sider. Again, I placed a small bend at the tip and placed the safe-sider in the oscillating handpiece. You can see by the milky color of the irrigant that material is being removed from the canal walls, and the walls are becoming increasingly clear of any remnants of pulp tissue. I had no trouble in once again skipping sizes to a 40 safe-sider with a 30-degree bend in the last couple of millimeters and taking it to the apex while again vigorously working all the walls. Please note the straight path to the apex where all the walls have been debrided of pulp tissue. After instrumentation, I dry the canals with paper points. I then pre-fitted my gutta percha points to be at the correct length with apical tugback. In this case, I fitted 2 medium gutta percha points. I placed easy fill epoxy resin cement on the pad and peaked it up to more efficiently coat the bidirectional cement applicator, taking it to a length in the tube 3 millimeters short of the apex. Note how I coat the applicator by placing it horizontally into the cement and then pull back at approximately a 45-degree angle. The cement is applied by using several up and down strokes in the canal or canals, staying 3 millimeters short of the apex. The flutes on the apical end of the applicator drive the cement coronally, preventing it from going over the apex, while the coronal flutes drive the cement apically. When the two flows of cement collide, the cement is driven laterally, which is our goal. Note how several strokes are all that is needed to drive the cement laterally throughout the length of the canal, save the last 3 millimeters. After coating the gutta percha points similarly to the way the applicator was coated, I placed the first gutta percha point and seared off the excess in the pulp chamber. I made room for the second using the Explorer to make sure the space for that point was still patent, trial seeded the second point, and then placed the second coated point into its space, searing it off within the pulp chamber. Note the three-dimensional fill attained as seen in the buccolingual and mesiodistal x-rays taken after obturation. We attained the results with three instruments. The safe side is 20, 30, and 40, with practically all work done in the 30-degree oscillating handpiece.